Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, double angle identities. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we used today, or even your own homework, you can always put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. Now, for some of you, I may have some extremely good news. If you're already pretty familiar with your angle sum identities, then finding your double angle identities is going to be a breeze. In fact, I would almost recommend don't even try to remember them, just start from your angle sum identities and recreate them. That's how simple it's going to be to derive your double angles from your angle sum identities. But if you hadn't seen my previous video on angle sum identities and angle difference identities, then you can check it out right up here. However, I have a quick reference for this video that I'll be putting right here. And like I said, this is going to be extremely simple. The main thing you have to do when you're starting from this angle sum identity for sine is change all the different angles to be the same angle. Here you have A and B, 2 different angles. But what happens if we just had A everywhere instead of B? So let's change all of the B's to A's. So let's rewrite this with, instead of A plus B, we have 2 A's. So now we have sine of A plus A equals sine of A times cosine of A plus cosine of A times sine of A. Now if we were to simplify this, we would get sine of 2A. And this is the start of our double angle. You have sine of 2A. Now we just got to simplify this part. Now we have sine of A times cosine of A plus a cosine of A times sine of A. Notice that this is exactly the same thing. We have sine of A's times cosine of A's. So you're adding the same thing. So instead of writing it like this, we can just say we have 2 sine A cosine A. 2 times sine of A times cosine of A. And this is exactly our double angle identity for sine. Simply starting with your angle sum identity, you just have to replace the different angles and make them all the same angle, then simplify. Let's try doing the same thing to find our cosine double angle identity. So here we're going to be starting with our cosine angle sum identity. However, before we get started, there are actually 3 different double angle identities we can derive from this one identity here. The first one's going to be done using the same thing we just did for sine, and we're going to be using the Pythagorean identity to take that next step from what we're going to get. And you'll see what I'm talking about in just a moment. So just like we did, we're going to replace all the B's with A's. So we're going to have, and when we simplify everything, we're going to get, we have cosine A times cosine A, which gives us a cosine squared A. We have a sine A times sine A, which gives us a sine squared A. And we're subtracting them just like this. This is going to be our first double angle identity for cosine. Now, if you recall, the Pythagorean identity is going to be sine squared x plus cosine squared x equals 1. So the goal is to get all of these in terms of cosine for one and all of these in terms of sine for the other, and then you'll get your other 2 double angle identities for cosine. So let's first start with replacing our cosine. Instead of having cosine squared A here, we can replace this with 1 minus sine squared A. That's simply just solving for cosine squared x of here, and we're going to see we're going to get this 1 minus sine squared A. Then we're going to bring everything else down, minus sine squared A. And then we're going to drop the parentheses because there's no need to have these parentheses here. And we're going to simplify some more. So we have 1 minus sine squared A minus sine squared A, which gives us 1 minus 2 sine squared A. This is going to be our second identity. So I'm going to write it right here so we can keep it. It was 1 minus 2 sine squared A. Now let's do the same thing, but instead of trying to get everything in terms of sine, let's get everything in terms of cosine. And in order to do that, we're going to have to replace this sine with 1 minus cosine squared A. Doing the same exact thing. We're solving for this sine squared, and we're going to get 1 minus cosine squared A. And bring everything down. We have cosine squared A minus this. And now we have to distribute this negative. So we have cosine squared A minus 1 plus cosine squared A. And now we have cosine squared A minus 1 plus this cosine squared A. We can combine these two cosines to give us 2 cosine squared A minus 1. This is our third double angle identity for cosine. So let me rewrite all of these so you can see them all one after the other. So now you see all three of them in one place. We have cosine squared A minus sine squared A. That's 1. We have 1 minus 2 sine squared A. That's the second one. And we have 2 cosine squared A minus 1. That's our third one. And to help you remember, I actually saw this and I thought it was pretty neat. Someone said you can think of this as 3 different flavors of your double angles for cosine. We have a vanilla flavored, a very plain vanilla flavor you can find almost everywhere. We have vanilla. We have our strawberry, right? Our strawberry. And we have our chocolate. So this strawberry is going to correspond with the sine, hence the S. Our chocolate is going to correspond with the cosine, hence the C. And our vanilla is just our plain, run-of-the-mill, normal identity. But we still have one more identity to go, and that's our tangent. So let's try to tackle that one in the same way we handled our sine and our cosine ones. So for tangent, we're going to do the same thing that we've been doing and start with our angle sum identity for it. And we're going to replace all the B's with A's. So we're going to rewrite this as tangent of A plus A equals tangent of A plus tangent of A over 1 minus tangent of A tangent of A. Now we simplify. We're going to have a tangent of 2A, tangent of 2A, and you have the same thing on the top here. Tangent plus a tangent. So we have 2 tangent A over 1 minus, and we have the same thing here, but they're multiplied this time. So we're going to have a tangent squared A. Up top, you're adding them, so you get the 2 tangent A. In the bottom, you're multiplying them, so you get a tangent squared A. And this is going to be our double angle identity for our tangent. So I hope you're able to follow along with today's video and help you see how simple it can be to derive your double angle identities. However, if you have any questions about what you saw today, or even your own homework, you can always put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, this is your playlist, and this has been another session of Tutor Me Sempai.